Hello and welcome to Podcast.init, the podcast about Python and the people who make it great. When you're ready to launch your next app, you'll need somewhere to deploy it, so check out Linode. With private networking, shared block storage, node balancers, and a 200 gigabit network, all controlled by a brand new API, you've got everything you need to scale. Go to podcastinit.com/Linode to get a $20 credit and launch a new server in under a minute. Go to podcastinit.com/GoCD to learn more about their professional support services and enterprise add-ons. And visit the site at podcastinit.com to subscribe to the show, sign up for the newsletter, and read the show notes. Your host, as usual, is Tobias Macy, and today I'm interviewing Moshe Zadka about Twisted, the original multifunction tool for asynchronous operations and network protocols in Python. So, Moshe, could you start by introducing yourself?
So my name is Moshe Zadka. I've been using Python since 1998. I've done some core contributing, and I've been part of the Twisted project since its inception around 2001.
And do you remember how you first got introduced to Python?
I was looking around for a language which had a good XML support with validation for schemas, and Python was the only language that had actually good libraries that I was willing to use. So I decided to learn Python.
And for anybody who isn't familiar with the Twisted library, can you share a brief overview of what it is and what it does and what are some of the things that people use it for?
It is a library for doing event-based programming, and that turns out mostly to be about network events, although not uniquely. So most of the things people end up doing with Twisted are network programs that includes both network clients and servers of various sorts, all the way from various web servers to things that send SNMP commands to routers.
And so you mentioned that you were part of the team at the point when Twisted was first being created. So can you share a bit about the origin story and how you got involved with the project?
So Glyph wanted to write a library for game programming that involved networks, and he was talking about it in channel Python on IRC, what is now Freenode. And I got involved mostly because I had some interesting ideas about how to implement protocols, and I really wanted a place to get a chance to try that out.
Do you know if Glyph was ever successful in actually creating the game, or did he get too far down the rabbit hole of building Twisted?
So that's actually a funny story. So the original name for Twisted was because the game framework was supposed to be Twisted Reality, and so Twisted.reality was the sub package that was supposed to have been the game. If you look at current Twisted, you'll see that reality has been deleted because it never actually got to a functional point. So not only did we not end up writing a game, we didn't end up even writing the proper game support library, just the networking part of it.
As is the way with such things. You set out with the best of intentions and then get waylaid, and instead you build a successful networking library.
Glyph keeps threatening that one day he'll write a game. I think the codename for that is Divunal. So if you look at his blog, he actually wrote something about it a while ago.
As somebody who's been a maintainer of the Twisted library for such a long time, what is your current role in the team, and how many people are currently involved in keeping the project moving forward?
So I don't have a specific role, although I've kind of done quite a bit of preparing teaching materials on that, but occasionally I'll try to review patches, and occasionally I'll help people fix bugs that bother them. I think it was like, depending on how you count, anywhere from 5 to 15 people who kind of semi-regularly work on it. It's a very changing crew depending on who has time and who wants to do something specific.
And so one of the things that I heard a lot when I first learned about Twisted was that it can be difficult to learn and get started with, and that people sometimes have difficulty wrapping their head around the programming model that it uses, particularly given the fact that it is so heavily asynchronous. So what are some of the resources or materials that you've found to be most useful for people who want to learn and get started with using Twisted?
So first, I'll say like what is the easiest way to get started with Twisted, because this has changed, and I think it's changed a lot for the better. So if you are starting now in 2018, just start using Python 3.6 with Twisted. And this means you can use the modern syntax support with async and await functions, and that will make a lot of things just a lot easier to get started with. So one resource that Glyph and I prepared, which actually doesn't use the async and await, but uses a very similar approach to kind of ease people up, is a tutorial we gave in PyCon 2017, which is obviously on PyVideo. We can put a link in the show notes. And we also had like the notebook that we used to give the tutorial as a resource for people who don't want to watch a 3 hour long video but just want to go through the exercises can do that. I think this is one of the nicest things. It's kind of it tries to teach from a very modern approach, Twisted. And I guess the other thing is that somehow a lot of other people are using async programming nowadays because Node.js is one of the most popular platforms, and browser JavaScript is even more popular than that. So I think some of it is just maybe people just heard that and kind of are a bit too scared, but it's actually easier than it looks, and literally everybody else is doing that.
And as one of the early movers in terms of building an asynchronous library and doing event-driven programming, do you ever sort of start shaking your fist at people who are praising the newfangled async frameworks and telling them that you've been doing it since they were in diapers? Or
Well, so a lot of people expected the Twisted people to react badly to that, but we're very happy. It feels like after like literally 15 years of shouting at everybody that async is not that hard, suddenly everybody got the message and everybody's doing that. So we're actually very happy to kind of finally have proven that this is a good way to go forward.
you have vindicated in your beliefs.
In our crusade, yes, definitely.
And I know that at least originally both Twisted and a number of the other asynchronous style libraries were heavily built around the notion of callbacks, which a lot of people will bemoan occasionally because of the fact that they can become very deeply nested and it becomes difficult to reason about the order of operations and when things are going to fire. And I know that a number of frameworks have moved more towards using futures or promises that are a little bit easier to reason about. So has Twisted followed along on that path as well?
In many ways, Twisted has led along that path. I think Twisted had deferreds since a lot of these did not have them. And you know what they say, that the pioneers have the arrows in the back. So deferreds were very early. And so they're pretty nice, but definitely a lot of the promises and futures, I have to say, are a little bit nicer than the Twisted deferreds, just because they had a chance to learn from the deferreds and not make some of the mistakes we made with them. But still, deferreds are pretty nice, and they really avoid the whole nesting thing with callbacks. And they've been doing that for like the last 15 years, so at least they're very stable.
And with the recent addition of the asynchronous support in Python 3.5, I think was the first inclusion, and more improvements with the async await and yield from syntax in the more recent versions of Python 3, has that eased your workload in terms of adding new feature support to Twisted? And what does the integration between the Twisted event loop and some of the other async engines in the Python ecosystem look like?
So I guess these are two different questions, but it's good that you have them together because people often confuse the two issues. So while async await was originally invented to help the async IO library, Twisted supported it since it began. So now I think even when Python 3.6 was in beta, we already had some async await support. So async await works pretty well in Twisted, just as well as it works in async IO. And it really has made Twisted programming really nice. So in many ways, I said that we were happy about other libraries coming along. And so the biggest way async IO has helped us is because it's developed by Python core. They're adding special syntax support for async programming, and we get to take advantage of that in Twisted. So this is actually pretty nice. As far as async IO integration, we've had the ability to run the Twisted event loop on top of the async IO event loop for quite a while, which means you can actually freely intermix it. We don't have the ability to do the other thing, to run the async IO event loop on top of the twisted event loop. And mostly that means that you don't get certain features in async IO, because you can get every feature in Twisted by running it on top of the async IO event loop. But if you say wanted to integrate async IO with GTK, then the easiest way would actually be to have async IO running on top of Twisted and take advantage of Twisted supports for GTK. I think people are working on that. That's definitely something we plan on supporting, but we don't have that yet.
And one of the things that I am often surprised by, and I know others are as well, is the breadth of protocols that are built into Twisted and that you can use for being able to tie together very disparate types of operations within the one library of Twisted. So, what are some of the most interesting or innovative uses of Twisted and its extensive protocol support that you've seen?
So one pretty cool thing that I think is now defunct, unfortunately, but a company was using Twisted to basically do router health management. So they were using Twisted's ability to support SNMP to send SNMP commands to a lot of routers and figure out what SNMP is. A simple network management protocol, and that's basically the native protocol most commercial routers use to report health and to manage themselves. And they had like this device that basically would manage a whole fleet of routers. And actually, Twisted was so efficient, it would occasionally kill the Cisco routers because it would send them requests too fast. And this is actually interesting, because some of the support we have in Twisted is like you don't want to obviously slow down your stuff, but you want to make sure you don't kill anything behind you. So we have actually pretty sophisticated support to make sure that you rate limit how much you send to a specific point or to a specific service. And this is always the story I tell when I introduce those tools. I tell the stories of the dying Cisco routers.
For the internals of Twisted, is it pure Python, or do you have any sort of Pythonized or C bindings for performance improvements?
So most of it is pure Python. There are a few little bits of C that basically the plan is to spin them out to a dedicated library so that we can do an optional dependency on them. I think one is for performance, but it's kind of an edge case. It's for a protocol very few people use, which is one of the reasons we want to make it an optional dependency. And one is actually for bindings to C functions that the usual Python library doesn't bind. I think some of the more esoteric Unix system calls that you need to do funny things with Unix domain sockets to send file descriptors on. They're not supported by Python natively, so we had to write our own bindings. But again, that's kind of like a pretty esoteric use case. So the plan is to spin some of those out into a dedicated library that just does the bindings, and then have Twisted do an optional dependency on them.
One of the things that I've seen in a few places is that people recommend using Twisted as the WSGI layer for web servers in place of some of the other options such as GUnicorn or MicroWSGI because of its performance capabilities and its asynchronous nature. And are there any other places that you tend to use Twisted either in your own work or that you recommend others use it for, where it isn't necessarily the first thing that people reach for?
Sure, but first, about the WSGI support, I actually have something to say about that. I don't think it's more performant than WSGI, but I think it still has benefits because very few people will run into the performance issues. But it's actually nice to have a pure Python library doing the web serving. That means that a lot of problems sometimes people run into WSGI with how it's built. For example, we have a problem at work with how it's built against SSL and it's doing something weird, and using Twisted for that just avoids these problems. And because Twisted was started out as a regular web server with the WSGI capabilities, it has built-in ability to do SSL termination and to do file serving. So often you don't need to do this thing where you put Nginx in front of your Gunicorn or in front of your WSGI. You can just use Twisted for what you would have used Nginx for, as well as what you as well as the WSGI server, and that simplifies operational complexity. The other thing I like to do with Twisted is I like to use it instead of Supervisor D. Supervisor D is certainly a respectable piece of software, but it is using the async support that Python 2.7 had that was so bad we had to write Twisted. And that's kind of a universal acceptance that it was really bad. Async IO was written because async chat and async core were not very good. And supervisor is written on top of basically a deprecated thing in Python 2.7 that is gone from Python 3. So instead of that, I like to use ncolony, which is a twisted based process manager. And it has a bunch of nice things like how it dynamically stops and starts services based on detecting files getting created and deleted. So it's pretty easy to do dynamic things. I like to put it inside my Docker containers. So when I Docker exec into the Docker container, I can literally just remove a file and have the main service shut down so I can start my own with debugging on or something like that. Obviously, it's not great to have to do it, but in the situations where you have to do it, it's pretty cool to be able to do it.
And what are some of the cases where Twisted is the wrong choice of library to use, or examples of places that you've seen people misuse it or abuse it where they would have been better served by some other piece of technology?
So, first of all, the simplest thing to write always is just a plain synchronous program that has one thread of execution, starts up, does something, then does the other thing, and if you're using Twisted for no good reason, it'll be harder to debug than just using something with one thread of execution. And the other place that Twisted would not shine in is if you have something very processor heavy, then you're probably better off just either using some C extensions and then using threads and releasing the GIL in the C extensions, or using multiple processors. But definitely Twisted is not for the case where your main bottleneck is a CPU, because it just like always with Python, you can only use one core at a time. So it's not going to be a good use of your machine if you're CPU bound.
And what are some of the ways that Twisted has evolved and changed over the number of years that it's been around?
So obviously we've added features, removed bugs, but I think the biggest evolution we've had is adopting much more rigorous development process. So we've sort of gone from one extreme to the other. In the beginning, it was kind of cowboy, and everything got checked into right into master without any thought. And we've developed a very rigorous and exception-free process called the Ultimate Quality Development System that I think by now is pretty much what everybody does. But back in 2004, it was kind of an innovation because we had this strict policy of branch-based development. So you always do any feature development on a branch, and you never start a feature unless there's a corresponding ticket, and you're not finished until there's a unit test that checks that you've done it correctly, and nothing gets merged without a peer reviewer. And I think most people, like now in 2018, follow some approximation of that. But back in 2004, with the very limited branching capabilities that we had there, it was really weird to do that. And I'm very happy we did it because it made that Twisted has gotten much more solid over the years.
And as part of the life cycle and evolution of Twisted, given how long ago it was started, is the process of upgrading it to run on Python 3. And from casual conversations with you and some of the other members of the team, I understand that that was a bit fraught at times. So I don't know if you want to talk a bit about the efforts that you had to go through to get Twisted to work with Python 3, particularly given the Unicode versus bytes issues at the network layer that is often problematic.
Yeah, so I think, among other things, I think Twisted put a very good pressure on Python itself to have better transitional plans. For example, adding the U prefix to strings in Python 3 so that you can have code that's 2 and 3 compatible was definitely a big part of it. And in general, the ability to write code that is 2 and 3 compatible. At the beginning, the plan was that you'll write your code in two, and then you'll automatically do 2 to 3, and you'll publish 2 libraries, and that's both operationally very complex, and I don't think anyone actually managed to follow that plan. And kind of part of a lot of libraries, but among them Twisted, had a hard time dealing with that, and eventually I think around Python 3.3, Python 3.4, core Python started adding enough capabilities to make writing code that is both 2 and 3 compatible more realistic, as well as the 6 library coming along and making it easier. And I think at that point, yes, we had a lot to think about the Unicode and bytes. I think a lot of that thought process was really good. Unfortunately, the internet is really complicated. A lot of the protocols that we support are like really, really old. IRC in particular has some very, very interesting thoughts about the semantics of bytes. So kind of reconciling them with the Python model of bytes are for lower level things and strings are for human visible things was non-trivial. But in general, I think that this distinction was very good for Twisted, because a networking library does have to make the distinction between what is a string that is supposed to be shown to human people and what is a sequence of bytes that is supposed to be sending over the network, and when do you add encoding information and all of that. So overall, I think Python 3 was good for Twisted, but I think it took time for core Python to really think about what a realistic plan for library transition looks like.
And as somebody who's been working with Twisted for so long, what are some of the things that you have learned in the process that were unexpected or most beneficial?
So I think one of the biggest lessons I've learned is how useful really, really good unit tests are. In many aspects of Twisted, I've kind of learned this lesson over and over again. And actually, the last point about this, the transition to Python 3 is really interesting. Part of transitioning to 3 was actually writing a lot of unit tests to make sure that we actually do run correctly on Python 3. So all the things that were in the past, especially the old code that wasn't very well covered by unit tests, writing unit tests for that and finding a lot of bugs. I really think that Twisted really hammered well in me the concept of unit tests are really, really important for code quality.
And one of the things that I found interesting in a previous episode that I did with Glyph about the event machine library that he wrote as a corollary to the work you're doing with Twisted is that by virtue of adding that event machine capability, you sussed out a few more bugs that didn't get caught by the unit tests. So are there any other additional libraries or tangential projects that have been spawned either as a result of the work on Twisted or to support the work that you're doing?
So I think one of the things that has been spawned, but I think it never really, so far it hasn't really solidified, as I keep hoping that someone will have time to work on it, is a pure Python SSL implementation that is based on very declarative ideas. Automat would be a part of it, but a big part of it would be how you declare the structure, the various structures that SSL has, so that you by definition can never misinterpret something, because a lot of the historical security flaws in OpenSSL come from the fact that two parts in the code don't agree on the interpretation of a certain sequence of bytes. I think we actually had something that started that, but it turns out to be a really hard project, and that actually spawned like a bunch of us kind of going off and kind of researching how to do protocols correctly and how to implement protocols correctly, and kind of it sparked a lot of interest in things like TLA plus in the Twisted community. So I guess it kind of relates to unit tests in the sense that traditionally in computing there are two ways to improve the correctness of something. You can test it a lot, and unit test is one way of testing it, or you can prove it correct. And Automat in many ways is part of the other tradition of proving things correct. And I think we've kind of gotten so good at unit tests, we've reached the limit of how well they can make your code higher quality. And now we've started to look into what kind of things we can get from the other traditional stream, from the side of proving things correct, from the making sure that things can't be incorrect by definition.
And your discussion about doing protocols correctly also brings up some of the recent movement of decoupling protocol implementations from the IO aspects. So I'm wondering how much of that is present in Twisted, where the protocol implementation can be taken on its own without necessarily having to tie into the asynchronous event loop that is the core of Twisted.
So there's a lot of sides to that. So when we started writing the protocol, I think the big plan was to actually make them what would now be called Sans.io, and some of the simpler protocols are actually written in Sans.io. But unfortunately, it's just too easy in a protocol implementation to kind of reach into the event loop and do something, and sometimes that makes you know it's very, at the moment it looks like a good idea, so a lot of the protocols unwisely reach into the event loop. So we do have some plans around that. Among them there's tubes, which is a library that's written kind of on top of Twisted, but you can actually decouple it and use it however you want, which is supposed to be this hierarchical protocol framework that is really supposed to just be bytes in, bytes out, and not think about event loop. And the other thing is that we are really happy to throw away all the protocol parsing code we have when there's a really good Sans.io library. So we're pretty much in the process of throwing away a lot of our HTTP implementation in favor of the projects from the Hyper Python project. So H2 and H11. I think we never had an implementation of HTTP2, and we just decided to not have an implementation of HTTP2. We use H2, and the way that Preface supports HTTP2 is just by using the Sans.io library, and we're in the process of basically removing the HTTP11 implementation, again in favor of just using the H11 library. So I think the biggest plan is that these things just don't belong in Twisted, and Twisted will happily use any Sans.io library that it can in favor of, instead of writing its own implementation. I think in the old days it was harder, but Python packaging has gotten a lot better nowadays, so we don't have any problem just depending on whatever libraries we need.
Given how long Twisted has been around, it's easy to sometimes allow it to fade into the background and forget that it is there and has played such an important role in the Python community for a number of years. So, what are some of the places that people are using Twisted that aren't necessarily the first thing that people think about, or that are maybe not quite as visible?
So it's always with open source projects, tracking usage is a little bit tricky. So often the only way we know that people use it is either they report a bug on the Twisted mailing list, or they hire one of us to help them. So I know Dual Security pretty much uses Twisted for all their web-facing stuff, so including like the actual security stuff. And Apple uses Twisted for their calendar server. So if you have an iPhone and your iPhone has a calendar on it and it's correct, then Twisted is involved in that story. And the newest user of Twisted is Matrix, which is supposed to be the kind of new replacement to IRC, and like really modern IAM, decentralized, and all the good stuff. And among other things, the French government has decided to standardize in Matrix to be the internal governmental communication tool. So now Twisted, I guess, is going to be in charge of securing all of France's government's communications.
It's a big responsibility.
Yep.
And what are some of the ways that people can support the Twisted project and the people working on it, or get involved and help to continue to bring it forward?
So there's a few things. First, we're always seem to be bottlenecked on having good reviews. As I said, we don't allow any code into the master branch without a peer review. And that is a good way to get in, because often people are a little bit worried about writing code for the project. But even if you're completely new to Python, just making sure that the code is clear and that it's obvious that it's doing the right thing is great. So just hopping on a review is super useful to the project. Of course, if you want to fix bugs in Twisted, we're more than happy to help. There's a mailing list and an IRC channel where there's always some of us happy to guide if there's an issue. And the other thing is, if you work for a company that uses Twisted and they would like to support us financially, Twisted has a record of using financial contributions very efficiently. A few tens of thousands of dollars a year is usually enough for us to manage to find someone to work on Twisted for a year. And basically, when we get that kind of funding, JP Calderon and Amber Brown have done it in the past, and they've done like really a lot of stuff on cleaning up Twisted and making it much better. So if you are working for a company that uses Twisted and they want to become a Twisted sponsor, we use money very efficiently and we are tax deductible.
And what are some of the plans that you have for the future of Twisted?
So some of the plans are really good integration with async.io. We've already shown some proof of concept about like literally running the AIO HTTP server on top of the Twisted event loop, which is useful for some use cases. But we want to do much deeper integration, so a lot of people are working on that. And then one of the other things we keep working on is actually taking bits from, like I said, Twisted in the old days packaging was really hard, so Twisted became very big because we didn't want to break it into multiple packages because every extra dependency was a huge pain. Now with modern PyPI, dependencies are a breeze. So we try to take bits of Twisted that could stand alone as a library and break them out into their own library. We move the code from Twisted and have Twisted depend on them. So a couple of the things we've done it with is the URL support. Now it's a hyper project called Hyperlink, and now Twisted doesn't have any URL support. It just uses the Hyperlink URL support, and we hope to basically eventually not have anything that's really called Twisted. Maybe it's gonna be a meta package that just depends on a lot of packages, but that's gonna be a slow process. But every single bit we can break out and make into its own library end up being a huge gain. So that's kind of one of the long-term plans for how Twisted is going to evolve.
And are there any other aspects of Twisted or your work with the project or anything related to it that we should discuss further before we start to close out the show?
No, I think we covered everything I had to say.
All right. Well, for anybody who wants to keep in touch with you and follow the work that you're doing and that is happening with Twisted, I'll have you add your preferred contact information to the show notes. And with that, I'll move us on into the picks. And this week, I'm going to choose the Leatherman Wave plier tool. I've been eyeballing it for a while now, and I finally picked one up. And it's a pretty great little multi-tool. It's pretty compact, has a lot of great little tools built into it, and I've been enjoying using that. Actually, came in handy a few times last week when I was building a deck, so it's great to have on hand. So with that, I'll pass it to you, Moshe. Do you have any picks for us this week?
Yes, so I wanted to recommend one of my favorite online books called Unsung Book. It's kind of hard to describe, but the easiest way I found to describe it, it's urban fantasy, but based on Jewish mysticism as the fantasy layer. And it's a really great book, and I think, not to spoil it too much, but I think there's a really good bit there for programmers. So I highly recommend if anyone finds that kind of stuff fun, they should check out the book.
All right. Well, thank you very much for taking the time to join me today and discuss the work that you're doing with Twisted. It's a very interesting library and one that has been a crucial piece of the Python ecosystem for a long time. So thank you for that, and I hope you enjoy the rest of your day.
Yep, thank you. And bye.